Hi everyone, my name is Ridwan, and in this lecture I'm going to be showing you how you can use text mining in R programming to analyze the book Oliver Twist. So first of all, we're going to load the libraries we're going to be needing. We're going to load the libraries we'll be needing. So we're going to be needing the Tidyverse package. So let's just load the Tidyverse package, then the tidy text package, which is used for text mining. So the tidy text package is a package that works on the principles of the Tidyverse. It is used for text mining in R. Then we have the Gutenberg package. So this package, the Gutenberg is a website of free ebooks. So this package actually takes data from that website, which you can use to perform text analysis. So there are free books which are available online. I'm going to drop a link to the site in the description. So these books are what has been, a package was created to fetch these books from the online repository. Then these books can be used for text analysis in R. So we have the Gutenberg package. Then we have the ggplot2 package. So the ggplot2 is going to load with the Tidyverse. So we are going, all is going to load with the Tidyverse, with the dplyr, and other packages we'll be needing in the Tidyverse. So these are the three packages we're going to be making use of. So let's load it. If you don't have it, you can use install.packages, Tidyverse to load it. So this is how you can install the package if you don't have it on your system. So now you can see our packages have already been loaded, the dplyr, the string R, the forecast, though we are interested in the dplyr and also the ggplot2. These are packages we are interested in the Tidyverse. So you can actually load it differently. So now let's load the book Oliver Twist. So I told that this book is available in the Gutenberg package, which fetches novels and books from the Gutenberg website of free ebooks. So we're going to use the Gutenberg metadata. So the Gutenberg metadata is where the book is stored in. Then we filter the book we're interested in by the title. So I'm going to filter by the title equals to Oliver Twist. So this is the book we're interested in. So why we're doing this is that I want to know the book ID number, because that is what we're going to use to create the book data. We have 3 books on Oliver Twist, so we're going to be using ID 730. So this is the Gutenberg ID. That is what we're going to be using. So we're going to use the Gutenberg ID 730 to create our book data. So we have Oliver Twist, Gutenberg download 730. This is going to fetch the data for us, 730. So our data set has already been created. So one thing you need to know about text mining. Text mining is actually the analysis of text data by transforming it into a structured form to get reasonable insight or patterns from that particular data. So we can't just analyze the data in that form. So we have to convert it to a structured data, then we have to start performing analysis on the data. So that is just all about text mining. So now I've already created a variable Oliver Twist that contains our data. So now let's have a look at this data. Head Oliver Twist. Let's have a look at the first 20 rows. So you can see that this data is in a structured format. So these are the rows. The data is in a structured format. But one thing I want you to take a look at is that if you look at this now, each row contains a sentence. So, and one thing with text analysis that we're actually analyzing the words in the novel. So there's what we call tokenization, in which these sentences are broken down into words. And also after tokenization, we're also going to remove stop words. So stop words are common words in English language. Since we are analyzing an English text, we have common words in English language. For example, words like I, be, we. So all those kind of words are words that are not actually going to contribute to our analysis. So we're going to also perform a tokenization, break these sentences into words, and also remove the commonly used English words. So we are going to create a variable called tidy Oliver Twist. That is a cleaned version of our Oliver Twist data. So we're going to say Oliver Twist. We're going to pass this to the unnext token. We're going to use the unnext token function. We're going to pass it to our unnext token function. So this is actually what is going to break down those sentences into words. If you look at it, the name of the column is text, and here we're having Gutenberg ID. So we're having two columns in this data. So we're going to say unnext tokens. We're going to create, unnext token is going to create a new column called word from the column text. So now we have already created the variable. We're going to create the variable tidy Oliver Twist. Now let's have a view of it. Head tidy Oliver Twist. So you can see now it has created a new column, removing the other column. It has created a new column called word. So this is actually what we are interested in. So I now said that we are going to be removing stop words, words like or and d. So why we are going to be removing these stop words is that we are not interested in analyzing these stop words, and I already explained earlier on that these are common English words. So we are not interested in analyzing them. We are interested in analyzing unique words in the text Oliver Twist. So now let's have a look at the data stop words that comes with the tidy text package. So this is it. So you can see this is what stop words. So you can see the words and you can see another column called lexicon. Now I want you to look at these two data, the stop words that comes with tidy text package and our tidy Oliver Twist data. If you notice now, I said that we want to remove the stop words. So I'm going to be using a filtering join function that comes with dplyr. So we have various filtering join functions, but in this situation I'm going to be using anti-join. So this anti-join is going to, as you can see, if we look at it, we have the stop words in this other data of stop words, and we also have words that are stop words in this our Oliver Twist data set. So this anti-join is going to take the words that are actually stop words in this Oliver Twist data set and remove them. So that means we are filtering out the stop words from the main data set. That is the tidied Oliver Twist data set. So let's do that now. I'm going to copy this, or let me just copy this so that it's going to overwrite the tidied Oliver Twist data. And now say anti-join stop words. Okay, let me show you something also to make some clarifications. So this was the previous one we did without the anti-join. So now let's take a look at the number of rows in this. Let's take a look at the number of rows in this n row. So we're going to say tidy Oliver Twist. So you can see we have 159,799 rows. Now let's load this one where we remove the stop words. We're having n row, tidy Oliver Twist. So you can see that after stop words have been removed, we are reduced to a number of rows of 57,525, meaning that we have a lot of stop words in that book, Oliver Twist. So this is what we are now going to be working with. We have already broken down the sentences into tokens, and we have also removed the stop words from the tokens. So now, when you now view our new data, head tidy Oliver Twist, let's view 20 rows. So you can see it, Oliver Twist Parish, and very sure by looking at this, you can see that these are not stop words. So now we have our tidied Oliver Twist data. The next thing we're going to go into now is word frequency. So we want to know the frequency of our words. We want to know the number of times a particular word occurs. So this is actually easy. We just say tidy Oliver Twist. Then we pass it into the count function. We are going to be counting the number of words and also sort it, which means it's going to sort for us from the by what descending order, from the highest to the lowest. So by doing this, you can see we have the most mentioned word is Oliver by 766. And we also have followed by replied 464, occurred 464 times. We have bumbled that occurred 366 times. As you can see. So let's also have a look. Let's have a look at the least occurring words. So let's have a look at it. We pass it to the function tail. So we can see we have yielding, yoke, young on, younker, youths, and zenith. As you can see, these are very, very unique words. I've never even heard of this. I don't even know the meaning. So this actually occurred once in the text Oliver Twist. So this is for our word frequency. Now we want to visualize this word frequency because they says a picture tells 1,000 words. So it's better if we show this word frequency in a visualization. So now we're going to pass this. We will not, because we are putting it in a visualization, we will not be able to visualize all the words. So we're going to filter words that occurred more than 200 times. So these words actually occurred more than 200 times. I'm going to be using the ggplots package AE and pass our coordinates aesthetics. So we're going to be using word as our x-axis and n, the number of times it occurs, as our y-axis. Then we are going to pass this to the geom column. And also flip it, because let's flip the plots. So you can see we have a nice looking plot here, but not that nice. We are going to make some adjustments, but first of all, let's just see when we are going to adjust. If you look at the plot, this is a bar plot. So that chord flip function I used earlier on flipped this, because if I'm going to use it without flipping it, it's going to I don't think the screen is going to accommodate all these columns, so I had to flip the graph plots. So now if you look at this now, you can see the bars, you can see our Oliver, the highest occurring word. You can also see other words like eyes, which in this particular graph now is the least occurring. I think should be around 200, a little bit above 200. Okay, now we want to arrange these columns, let's say in ascending order or in descending order. It looks much more better than way I'm appealing to that. I also want to give a color to it. You know, colorful things are more attractive. So let's see what we're going to do. First of all, this word we are going to change it to reorder. We're going to use the reorder function. So it's going to reorder it by n, by the number of times the word occurs in our graph. This is going to reorder it. And then we are going to fill. We are going to give fill is equals to word. Yeah, we're going to give fill is equals to word. Fill is equals to word, so it's going to fill these columns by the particular words. And also y is equals to null. Then x, let's just say y is equals to null. Since we all know we are dealing with words, then x we say type, then x is equals to word. And we have title is equals to most common occurring words. Most common words in Oliver Twist. So let's run these and see. Yeah, much better. So you can see it. So you can see most common words in Oliver Twist. You can see that the plot now is in descending order by descending by the number of times a word occurs. So that is all for our word frequency visualization. Let's actually reduce this to 10. Let's see. So let's reduce it to 10. Or let's just give a much more higher benchmark. Let's say 300. Let's give a higher benchmark. So I think we can make do of this. It's much better. So we can see now, we can see Oliver occurring first, occurring most, replied, bumble, sykes, time, and gentleman. So one thing with these words is that by actually knowing the words occurring most in a book, someone can know what the book is actually about. So we know the book is about Oliver. We can see replied. So this replied is actually telling us that is it possible that Oliver is a servant, or Oliver is maybe has someone that is always that is under him, but because replied occurs very well, Oliver replied, this replied. So replied is occurring frequently. We have bumble, we have sykes, we have time, and we have gentleman. So that's for the word frequency. Now let's go to one of the most interesting parts in text mining, which is sentiment analysis. So this is the analyzing of the sentiment of a particular text. And before I dive into it, I want you to know that we usually use lexicons in sentiment analysis, because sentiment analysis is like, let me say, want to know what, like grouping a word into either positive or negative. So we have various ways of actually performing this grouping. So this is just a layman explanation. Let's say grouping the words into positive or negative, or maybe into happy or sad. Are these words signifying someone is happy or signifying someone is sad? So we have various lexicons we actually use in classifying the words we have in a text. We have the FINN, which is a range of -5 to +5 with negative scores, indicating whether a word is negatively sentimented or positively sentimented. And we also have the BINC, which classifies into positive and negative. This is what I'm going to be using in this video. And we also have the NRC, which classifies into positive, negative, anger, anticipation, disgust, fear, joy, sadness, surprise, and trust. So if you can see that the NRC classifies a text into positive, negative, anger, anticipation, disgust, fear, joy, sadness, surprise, and trust. So this is 10 classification. So that is what the NRC actually does. If I were you, I would take this as an exercise. So once I use the BINC, I think you should be able to understand where I'm going to change the code and see how your text will be classified using NRC or FINN. So let me perform the sentiment analysis on our text. So we have tidy. Let's create a new variable called Bing word counts. And we have tidy Oliver Twist. So now you can see now we're going to be using another join called inner join. So what this is going to do now is going to take the words that can actually be sentiment, that actually are present in our lexicon. So let's say inner join get sentiments. So this is going to get our sentiments from the lexicon BINC. So this is where I'm going to be changing. If you want to use AFINN, you change it to AFINN. If you want to use NRC, you can use NRC. But I'm going to be using BINC because BINC will classify it into positive and negative words. So you can see you pass your inner join to get sentiments BINC. So this inner join is going to take the sentiments from the word BINC that are actually in your data set. So any word that is not in your data set, this inner join is going to exclude it. So it's going to only take words that are present in your data set. Then we have count. We're going to count these words. Sentiments. Count by sentiment. Then we're going to sort. So we already have it. Let's have a look at the data. Bing word counts. So you can see it, the word master, it is a positive sentiment and it's occurred 107 times. The word poor is a negative sentiment, occurred 98 times. The word dark is negative and occurred 79 times. So this is actually showing us the sentiment of this word. So we now know that master is a positive word, poor is a negative word, dark is also a negative word. So then we next are going to visualize this sentiment. We're going to present it in visualization format. So now we're going to make a visualization of the most common positive and negative words. So we're going to use our Bing word counts. This was the data we created. Bing word counts. We're going to pass it to the function group by. It is going to group by sentiment. Then we're now going to slice max. So we're going to use the slice max function. So this slice max function is going to slice our data set into two. So if you can see now, we're going to slice it by n. So you can see slicing by n, because we grouped it by what? Sentiment, negative, and positive. So it's going to slice it into two. That is based on this word sentiment, because we have two sentiments. If we have to have three sentiments, we are going to be seeing three sentiments in this place. And now take the highest word that is occurring in each sentiment. So you can see that in the positive sentiment, 107 occurred most frequently, while in the negative sentiment, 98 occurred the most frequently. Now, what we want to also see for other ones, they want to see for 10. That is 10 for each particular sentiment. Mind you, we have already grouped it by sentiment. So it's going to be showing us the number of variables by each group, number of rows for each grouping. So it's going to show us now 10. We want it to show us 10 rows for each, or 10 words for each grouping. If we are to do that, or let me start with 5 so that you can see what I'm meaning. So by 5, you can see we have 5 of it. As you can see, it's going to show us the most occurring words under the negative sentiment and also the most occurring words under the positive sentiment. So this is what the slice actually does when used with the group by function. So the slice is going to slice it by each grouping. It's going to take each grouping and give you the number of rows you want. So now let's change it back to 10. So by 10, I'm going to have 10 words under negative sentiment, and I'm going to have 10 words under positive sentiment. So now let's pass this into the ungroup function. Let's ungroup it because we are going to be visualizing it right away. And we are going to use the ggplot to visualize our data. So we say x is equals to n and y is equals to reorder word by n. So we want our graph to look ordered. Then we are now going to pass fill, which is equals to sentiment. So the bars of the plot are going to be filled by sentiment. So we have geom call. So we don't want a legend to show. So I'm going to say false. When we do this, so this is what we have, as you can see. So you can see now we have it, but we still have a lot of things to do on our graph, because if you can see, it has not actually grouped it for us into positive and negative sentiment, because we have the red ones as the negative sentiment and we have the blue ones as the positive sentiment. So now this is what I'm going to do next. I'm going to use the facet wrap. So in one of my videos, I've explained about the facet wrap. I'm going to drop a link in the description. Facet wrap sentiments. I'm going to pass it to sentiments because we want it to facet the plot by sentiments. And say scales is equals to free y. So you can see now we have on one side the negative words and we have on another side the positive words. So, and also a very important thing, we should not forget our labels, labs, x is equals to contribution to sentiment, and we also have y is equals to null. So now let's have a view of our graph. So now we can know the negative and the positive words in the text Oliver Twist. So you can see these are the top 10 negative words in Oliver Twist and the top 10 positive words in the text Oliver Twist. The last thing that is left for us now is for us to visualize our sentiment analysis using a word cloud. So word cloud is another way of visualizing the sentiment analysis, which is going to be showing us the most frequently occurring negative and positive words. So we need to load the word cloud library. So if you don't have it, you can install it using the install.packages. Then we also load the reshape library. So I'm going to be seeing the reshape 2 library. I'm going to be seeing why we are needing the reshape 2 library. So we're going to load these 2 packages. So our data that have the sentiment is the being word counts, the data we create earlier on that have the sentiment. So let's have a view at it so you can see the being word counts data. What we want to do next now is to make each sentiment a column. So each sentiment, instead of us having the column sentiment and number of times a word is occurring, we're going to be having positive and negative. Why the values that the word is going to be holding is the number of times they occurred. So I'm going to pass this into the acast function. And we're going to have rows as words and columns as sentiments. So the sentiment values are going to be the columns. Then our values is going to be the number of times a word occurs. When we run this, so you can see that we have each column as a sentiment, negative and positive, and we also have the words. So the fact that a word is a negative sentiment, that means it cannot be a positive sentiment. So that is why we're having missing values. So how do we now treat these missing values? This is where we're now going to be using fill is equals to 0. So you can see we no longer have missing values. Then we can't visualize our sentiment analysis in a word cloud if we don't convert the being word counts data into this format. We can't visualize our sentiment analysis into a word cloud if we don't convert it into this format where each row is a word and each column is a sentiment. So that is why we use the reshape 2 library to actually convert it into a table. So we call this like a table where we have negative, positive, and the values is the number of times a particular word is occurring. So now I'm now going to pass this into, we're going to pass it into the comparison.cloud function. This is going to plot our word cloud. So our negative sentiment is good. We are going to give it the color C, and our positive sentiment the color cyan. Then the maximum number of words we're interested in is 50. So let's run this. So as you can see on the screen, this is our word cloud. You can see our positive words in cyan and our negative words in red. Whereas we have already seen earlier on, poor is the highly occurring negative word and master is the highly occurring positive word. So this is another way of also visualizing your sentiment analysis using the word cloud. So that is all for analyzing our book Oliver Twist.